Application of electrostatic force. I'll solve this problem today. In the problem it's given two identical small charge spheres. These are two spheres, each having mass m. Mass of each sphere is m. Hang in equilibrium. This is equilibrium situation. Find the magnitude of the charge on each sphere. The task is to find this charge q in terms of L, in terms of theta, and in terms of m. When two charges are there is an electrostatic force called Coulombs force. The Coulombs force between the two charges separated by distance x, because the two charges here given are positive, therefore there is a repulsive force. Now consider this mass m of charge q. Force on this is q square upon 4 pi epsilon naught x square. In the previous class I was taking kq square upon x square. Here I am considering it is in vacuum, so k is 1 upon 4 pi epsilon naught. The force is q square upon 4 pi epsilon naught x square, and it is a repulsive force, therefore on this charge it is towards left. Another force is on this mass m is, because of gravitational force, there is a downward weight mg in the downward direction. Now this is a string. In the string some force is developed. Consider T be the tension in the string. Let this force in the string to be T. Length of the string is L. Now this is a case of equilibrium, so I should resolve T into two components, T cos theta and T sin theta. Let me resolve this T. This angle is theta, so this angle is also theta. So T in this direction is T cos theta, and T in this direction is T sin theta. This is an equilibrium. It means T sin theta should be equal to this force and T cos theta should be equal to mg. So I should write the two equations. One is T sin theta is equal to q square upon 4 pi epsilon naught T sin theta is equal to q square upon 4 pi epsilon naught x square. This is equation number 1. The second equation is T cos theta should be equal to mg. T cos theta should be equal to mg. For the case of equilibrium of these two charges, these two should be the equations. If the two spheres are in vacuum, if in some problem that it is given that the whole apparatus is in a liquid, in presence of liquid there will be two changes. One change will be there will be upthrust in this direction, upthrust. According to Archimedes principle, upthrust is equal to weight of liquid displaced. Second is this will be modified and it will become q square upon 4 pi epsilon naught into x square. And then two different equations will be there, and then solve those two equations. But in this question, I am not considering any medium. I am taking vacuum. So these are the two equations. Now T is unknown. Let me eliminate T. Perform 1 upon 2. If I perform 1 upon 2, I'll get tan theta. T sin theta upon T cos theta is, T will be cut out, tan theta is equal to q square upon 4 pi epsilon naught x square mg. So using this, q comes out to be equal to q comes out to be equal to 4 pi epsilon naught x square mg tan theta under root. This is the equation. Task was to find charge on each sphere. Charge comes out to be this. This is one of the problems. In another problem, I found this should be the beginning of the second problem. Let me show the second problem. Same type of detail is given. Then it's given, it's asked, charge begins to leak. Question is charge q begins to leak from both spheres at same rate. It means dq by dt on both the spheres is same. Charge begins to leak at the same rate. Find speed of the ball with which the balls approach each other. This is the second question. This is the second question. Come here. In the second question, this charge q is not same, but it is decreasing. When charge is decreasing, then this repulsive force will decrease and they will come closer with certain speed. Task is to find the speed with which they are approaching each other. So I should start with this equation. This equation says q is equal to 4 pi epsilon naught x square mg tan theta. In these type of problems, it's always given that theta is small. When this theta is small, then tan theta is approximately sin theta is equal to, this distance is x by 2, is equal to x by 2 arc upon radius l. So put this tan theta there. It will become q is equal to 4 pi epsilon naught x square mg x by 2 l under root. So it is q square is equal to 2 pi epsilon naught mg upon l. mg upon l under root into x to the power 3 by 2. This is the equation. Q is equal to this, not q square, just q is equal to this. So in this equation, q is a function of separation x. If I differentiate this equation, on the left hand side I'll find dq by dt, on the right hand side I'll find dx by dt, and dx by dt is nothing but velocity with which the two spheres are approaching each other. Now differentiate this equation. If I differentiate this, I'll find dq by dt is equal to 2 pi epsilon naught mg divided by L into, if I differentiate x to the power 3 by 2, it will be 3 by 2 x to the power half into dx by dt. And what is this dx by dt? Dx by dt is velocity with which the spheres are approaching. So using this equation, I can solve the second type of problem. So I have discussed two problems using Coulombs law. In this diagram, let me discuss few details. I have written here. I have termed them as notes. First part, consider Q1 and Q2 are not same. Q1 is greater than Q2, but their masses are same. When their masses are same, then mg will be same, the downward force is same, but this force F, because Q1 and Q2 are same, Q1 and Q2 are unequal, but F is F1 is equal to F2 will remain same, which is K Q1 Q2 upon distance square. It will remain same. Because this repulsive force will remain same and masses are same, therefore downward force is also same. Therefore in this case, this theta1 and theta2 both are equal to theta. Now see the second case. In the second case, if m1 is greater than m2, if charges are different, then repulsive force will be same. But when masses are different, then m1 is greater, so m1g is greater. The downward force on the sphere is greater than this. So see, for obvious reasons, this angle will be smaller, this angle will be larger. So in this case, I can say when m1 is greater than m2, theta1 is less than theta2. Third type of situation I have found in the MCQ questions is that apparatus, the whole apparatus is placed. This apparatus is placed in a satellite. This apparatus is placed in a satellite. In case of a satellite, it is weightlessness. Net acceleration due to gravity is 0. So put g is equal to 0. Therefore m1g is equal to 0 and m2g is equal to 0. And there is no downward weight. There is only repulsive force. So this will be the result. The angle between Q1 and Q2 will be 180 degree. And for tension in the string will be equal to F1 is equal to F2, and tension in the string will be equal to kq square upon 2L whole square, because 2L is the separation between the two charges. That's all for today.